Hello students. So this video is about questions for magnetic circuits. So I've written the first questions and I have highlighted the parameters. So the question goes like this, that there is a closed magnetic circuit of cast steel containing a 6 centimeter long path of cross-sectional area 1 centimeter square and a 2 centimeter path of cross-sectional area 0.5 centimeter square. A coil of 200 turns is wound around the 6 centimeter length of the circuit and a current of 0.4 ampere flows. You have to determine the flux density in the 2 centimeter path if the relative permeability of cast steel is 750. राइट तो इसमें मैग्नेटिक सर्किट में कास्ट स्टील है जिसमें दो पाथ हैं, एक 6 सेंटीमीटर लॉन्ग है राइट जिसका क्रॉस सेक्शनल एरिया है 1 सेंटीमीटर स्क्वायर और दूसरा पाथ है 2 सेंटीमीटर लेंथ का जिसका क्रॉस सेक्शनल एरिया है 0.5 सेंटीमीटर स्क्वायर। एक कॉइल है जिसके 200 टर्न्स है राइट जो कि वुंड हुई है यानी रैप अराउंड हुई है किसके 6 सेंटीमीटर लेंथ ऑफ द सर्किट के और करंट कितना फ्लो कर रहा है 0.4 एम्पियर। आपको निकालना है फ्लक्स डेंसिटी किसमें 2 सेंटीमीटर पाथ में and the relative permeability mu r जिसको हम बोलते हैं given is 750. So let's see how we will now solve this question. Right now what I will do, I will first see for the 6 centimeter long path. Right, मुझे क्या मिल सकता है reluctance. राइट फ्लक्स डेंसिटी सो सिंपल सा लॉजिक है, आपको निकालना है फ्लक्स डेंसिटी विच इज बी राइट। बी क्या होता है फाई बाई ए, एरिया आपके पास है फाई नहीं है, फाई मतलब फ्लक्स। फ्लक्स किससे मिल सकता है एमएमएफ और एस से। एस क्या है रिलक्टेंस राइट। रिलक्टेंस अब हम दो पाथ की निकालेंगे, एक निकालेंगे रिलक्टेंस S1 जो कि 6 सेंटीमीटर लॉन्ग है और दूसरे निकालेंगे 2 सेंटीमीटर और इक्विवेलेंट रिलक्टेंस निकालेंगे राइट। सो लेट्स गो विथ रिलक्टेंस S1 विच इज L1 अपॉन म्यू नॉट म्यू आर A1. So what is the length given for the first case is 6 centimeter, so I convert it into meter. The whole divided by 4 pi into 10 power minus 7 is mu naught. Mu r is 750 and area 6 centimeter long का है 1 centimeter square which means 1 into 10 to the power minus 4 meter square. Right? ये S1 आपका आएगा 6.366 into 10 to the power 5 Henry inverse. ठीक है, उसके बाद हम निकालेंगे for the 2 centimeter long path. Reluctance निकालेंगे right. This reluctance is S2 which is L2 upon mu naught mu r A2. ठीक है, अब लेंथ क्या है 2 into 10 power minus 2 meters. म्यू नॉट है 4 पाई into 10 power minus 7 into 750 is mu r into A2 which is 0.5 into 10 power minus 4 meter square. S2 की वैल्यू आपकी आएगी 4.244 into 10 power 5 हेनरी इनवर्स। ठीक है, अब आपको निकालना है टोटल रिलक्टेंस। टोटल रिलक्टेंस S जैसे कि सीरीज रेजिस्टिव नेटवर्क में होता है R1 प्लस R2, हियर इट इज S1 प्लस S2 राइट। ये हो गया आपका 6.366 प्लस 4.244 into 10 power 5 Henry inverse which comes out to be 10.61 into 10 power 5 Henry inverse right. Total reluctance is given by MMF over phi, or I can write phi as MMF over S. ठीक है, MMF क्या होता है N into I, number of turns into current over reluctance. Therefore, now my phi that I can now calculate N as 200 turns. I know current है 0.4 amperes divided by the total reluctance which is 10.61 into 10 power 5. ये टोटल हो गया आपका 7.54 into 10 power minus 5 वेबर्स. राइट नाउ आपको निकालना है फ्लक्स डेंसिटी इन द 2 सेंटीमीटर पाथ. 2 सेंटीमीटर पाथ का एरिया कितना है? 0.5 centimeter square, which means now I can say that the flux density, right, in 2 centimeter path length, right, B is equal to phi over A. This phi is nothing but 7.54 into 10 power minus 5. The whole thing upon 0.5 into 10 power minus 4 meter square area, which gives me answer as 1.51 Tesla. Right? So the flux density in 2 centimeter path length is nothing but 1.51 Tesla. This is your answer. Right? So whenever you read a question, आप उसके parameters को अलग से लिख भी सकते हैं, right? And so you know what is available and what you have to find out. I'm moving on to the second question, which says that a cast steel magnetic structure made up of a bar of section 2 cross 2 centimeter, right, जो कि नीचे draw किया हुआ है, right, determine the current in 500 turns magnetizing coil. तो magnetizing coil मतलब the excitation, right, which is on the left limb. So it should carry a flux of 2 Webers getting produced in the right limb, right? यानी कि इसमें जो ये phi r है, सॉरी, ये जो phi r है, this will have your flux to be as 2 milliwebers, right? And you can take mu r to be 600. So again, let's see हमें क्या क्या given है. Now looking at this picture and question, area is given to be 4 centimeter square. This is clear, right? So it's 4 into 10 power minus 4 meter square. N is given to be as 500. ठीक है. Mu r given है 600, right? Phi r means flux on the right limb, right? So L is left, C center, R is right, is given to be 2 milliwebers, right? और बाकी दिए हुए हैं lengths, right? So let's go to the length for the left one, left limb, right? You can see at the top 25 centimeter. Length for the center one is 15 centimeter, जो green में है, right? And length for the right one is again 25 centimeter, right? तो इस सर्किट का सबसे पहले I will make an equivalent electrical circuit to make it easier to understand, right? तो ये मेरा excitation है Ni, right? यहाँ से reluctance जो कि अभी के लिए मैं इसको लेबल कर सकती हूँ SL, right? ये मेरा सेंटर का है which is SC, और ये मेरा से राइट का है SR, right? उसके बाद what I also know is the flux in the left is labeled as phi L, the flux in the center is labeled as phi C, the flux in the right is labeled as phi R, and this is given to me as 2 milliwebers. ठीक है. So now as we do it always, हम इसमें सेम रूल्स लगाएंगे जो इलेक्ट्रिकल सर्किट के लगते हैं, right? So say the first rule that I apply here is that the mmf, right, in the center limb is same as mmf in the right, राइट mmf किसका इक्विवेलेंट होता है emf का, इलेक्ट्रोमोटिव फोर्स का, किसमें, इलेक्ट्रिकल सर्किट में, which means your potential drop across the parallel branches is the same. It's the same logic here. तो mmf को हम कैसे लिखते हैं, say phi c sc, so phi is flux, s is reluctance, is same as phi r sr, right? Or I can write phi c to be equal to phi r into sr divided by sc, right? अब phi r को आप क्या लिख सकते हो, 2, क्योंकि आपको दिया हुआ है 2 मिली वेबर्स. एस आर का इक्वेशन लिखेंगे, राइट, एल आर अपॉन म्यू नॉट म्यू आर ए, द होल थिंग अपॉन एल सी अपॉन म्यू नॉट म्यू आर ए. Mu naught mu r is the same for both the branches and a is the same, right? So we are left with 2 lr over lc, which can be now written as 2 into, what is lr, 25 upon lc, which is 15. This gives me a value of 10 by 3 milliwebers, right? दूसरी चीज़ अब हम लगाएंगे that the flux, say reaching at, now look at this circuit at the top, at point A, right, is getting divided into phi c and phi r, right? So I can say that also if I apply KCL, phi L is nothing but phi c plus phi r, right, which becomes 2 plus 10 by 3, which is 16 by 3 milliwebers, right? Now अब हमें निकालना है the current, right? Look at the question. You have to determine the current in what, in 500 turns magnetizing coil, right? Which means अब आपको निकालना है इस करंट को, जो मैंने यहाँ पे I लेबल कर रखा है सर्किट में, right? I को आप कैसे निकालोगे, आपको लगाना पड़ेगा KVL, right? KVL हम कैसे लगाएंगे, now if you see carefully, here there are 2 loops. One loop is this, right? The other loop here is this, है ना? ऐसे ही हम KVL में लगाते हैं, we choose which loop we want to use, right? Either I use the smaller loops or I use the bigger loop. So here I choose to use the bigger loop and I say Ni is equal to, this is as per KVL, right? Ni is equal to phi L, right, SL plus phi R SR, right? अब phi L कितना है, अभी हमने निकाला 16 by 3, right? And then I say into 10 power minus 3, right? Into SL की वैल्यू क्या होगी, LL over mu naught mu r a plus 2 into 10 power minus 3 into SR की value, which is LR over mu naught mu r a, right? When I put the values of LL, which is 25, LR, which is again 25, please make sure you convert it into meters, right? And I put the value of mu r to be 600, right? और area भी इसमें given है, right? 4 centimeter square, तो 4 into 10 power minus 4 meter square. इसमें आप जब सारी values डालोगे तो Ni आपका आ जाएगा 6078.835 amperes turn. Therefore, if I have to now calculate I will divide this term of Ni by the number of turns, which is given to me as 500, and I get it as 12.15 amperes. So the answer to this question is that the current flowing in the magnetizing coil is 12.15 amperes, right? So any question you get, please see if it's a series connection, it's a parallel, or is it a mix, or is it a composite, right? फॉर्मूले आपके वही 3-4 हैं जो आपको याद रखने हैं, that you can apply and solve any question, right? Okay class, thank you.